Hey everyone, welcome to Extreme Makeover Jupyter Notebook Edition. I'm Izzy Miller, a developer advocate at Hex, and I'm here with
Ariel, Zahler, Harnik, and I lead partnerships.
And today we're going to talk about Jupyter Notebooks, why they're so awesome, why they're kind of not so awesome sometimes, and we're going to actually show you how to make them better. I think we'll start by talking a little bit about Jupyter Notebooks before we dive straight into them. This is a Jupyter Notebook. If you're not familiar with the ancient lore of Jupyter Notebooks, they're actually a pretty old concept. The first notebook style tool, Mathematica, was actually invented all the way back in like 1980. And this version of the notebook, Jupyter, or what was originally called the IPython notebook, was first released in 2011, I think. So they've had some time to percolate and become the sort of de facto tool for doing data analysis and science. And they're really great because, as you can see, they have this really interactive, almost REPL-like evaluation where you write some code, a pretty small amount of code in a cell, and you run it, and you get an output. And then based on that output, you can write more code. So here we're running a query, we're looking at the output, and then we're writing more code. And that sort of read, evaluate, print, and then do that over and over and over again is like an incredibly efficient tool for doing data analysis. And this is really the other secret weapon of Jupyter Notebooks, which is that there's just some text up at the top of this screenshot interspersed with code and interspersed with visualizations. And this sort of literate programming concept where the code is almost self-documenting in the sense that you could send this to somebody and they could see, oh, okay, I know what this code is doing because right here, there's a heading that is saying which popular venues do people stay at the longest. So people can understand a Jupyter Notebook a lot more than they can understand, say, a random Python script file with a couple crappy inline comments that you email them. So they're really, really popular for all of these reasons. But
the times are changing and a lot has changed since 2011. The era of the modern data stack has pushed more and more workloads way up into the infinitely scalable cloud, and data volumes and processing requirements have increased accordingly. But notebooks, on the other hand, haven't really kept up with the changes. And today, they kind of feel like relics, despite being used for analysis and modeling workflows by thousands of data practitioners. The rest of the tools in the data stack have actually evolved nicely. But for the most part, when it comes to crunch numbers, analysts and data scientists are firing up those old Jupyter notebooks on their laptops and siloing themselves off from collaboration and limiting their compute resources. Jupyter notebooks actually have a number of flaws. The first is that they're not designed for cloud scale SQL. They don't have any of the polish of a traditional SQL IDE. The second is that there are constant state issues, which makes it extremely difficult to reproduce the output of an end-to-end notebook. Running cells in a different order can actually output an inconsistent result. The third is that collaboration is siloed. Working with team members on a problem requires constant emailing of Jupyter notebooks or collaborating outside of the tool, like in Slack or maybe in Google Drive. And lastly, sharing is basically impossible. Jupyter was actually supposed to make this easy. But if you want to share a notebook today with a team member, you have to walk through a painful workflow of either emailing the notebook file or creating a repo, checking it in, and then setting up a number of access requirements. So let's show you how you can actually fix this.
all right, so we're going to jump straight into an actual Jupyter notebook. So this is a Jupyter notebook that we made the other day. Let's pretend that I'm a data analyst at a restaurant company that hasn't yet started up and built any restaurants, but we're really interested in doing so. And we want to build some restaurants in San Francisco. And we're trying to do a little bit of market research on what kind of restaurant we should build and how we should run our initial marketing campaigns. My boss's hypothesis is that there's a correlation between the weather and people's likelihood to eat or stay at certain restaurants. So they've tasked me with finding out if this is correct and running an analysis on weather and restaurant visits in San Francisco and a couple other cities. If you use notebooks, a lot of this is really familiar. We'll sort of quickly run through a lot of the key points. Here I'm installing a bunch of packages. You'll notice that this code is commented out because I've already run it once, and so I don't need to run it again every time I've run this project. So I've commented it out here. And then here I'm importing all these packages, creating a connection to Snowflake, and running some SQL queries against Snowflake marketplace data to get a bunch of weather data. I do the same thing against some data about Foursquare restaurant visits to get a sort of baseline for what people are doing and when. And then the rest of this section is mostly about cleaning, exploring, removing some outliers from this data, and then doing a little bit of feature engineering to get our data ready for machine learning. We're going to just add some categorical columns to pull out cloud cover, humidity, and temperature. If you look up here, you'll notice that there were some other variables like snow depth and cloud cover, which aren't present in all of our cities. Like San Francisco doesn't have any snow depth. So we're just going to remove that for now and focus on temperature, humidity, and cloud cover. So we do a little bit of feature engineering to clean this up, and then do just some general exploratory data analysis to parse through it. We actually build a map, which I guess we can see if I trust this notebook. We'll go back to that map. So we can really interactively explore this data set and see what the most popular restaurants are in each city. So in San Francisco, given our current weather parameters, it looks like this Burger King down near Hunters Point or Bayview maybe is the most popular. But our real question is, does humidity or other weather values affect visit times? So we plot this and it doesn't look too good. This chart doesn't seem to show a huge amount of correlation except for some spikes at the highest levels where maybe it's like pouring rain and people don't want to leave restaurants or get stuck. But outside of that, it doesn't look like there's a huge amount of correlation. Just to be certain, we're going to run a quick regression analysis and do a little modeling using random forest regressor and try and predict visit times based on this data to see if we can do that accurately. And we can't do it that accurately. We can get within around 11 minutes of the actual duration of a restaurant visit based on weather variables. But given how long people tend to spend at restaurants, that's not the most useful numbers. These are mostly chain restaurants. So we're going to go back to our boss and tell him that there doesn't seem to be a huge correlation, even though humidity is the most predictive. But I want to send him this Jupyter notebook. The problem is that whenever I run it, it takes like 10 minutes to run. And sometimes there's a lot of errors. I've actually tried sending this to a colleague and they weren't able to get it to run. So I need my friend Ariel to help me load this into the cloud and clean it up and make it run faster and more reproducibly.
Awesome. Let's upload this Jupyter notebook to Hex and actually bring it into the cloud era.
Okay, so here I'm in Hex and I'm gonna click import project and then I just upload my notebook.
Yep, you can simply just drop your Jupyter notebook right inside of Hex and it'll break out into those same cells that you're familiar with.
Sweet. Okay, I'm uploading it. Okay, it's uploaded. This looks a lot like the other Jupyter notebook layout. I see I have my cells, but there's some other stuff around here too. Is there anything I need to do to set this up before we get started?
So I think the first thing we'll do is over on the left-hand side, we'll jump over to the environment section and change it to 3.8. This will allow us to actually use Snowpark throughout our notebook.
Sweet. I think I might as well crank this puppy up to an extra large too while we're at it. And I'll give this notebook a name because notebook parentheses 2 is sad. Weather and restaurants. Sweet. Okay, so can I just hit run all and run this thing?
So you can, but Hex actually has a couple things that we can make it easier in this notebook. So the first is that you don't have to deal with importing all of these packages as you were doing before. Hex is actually a fully hosted notebook solution and a number of these packages are already pre-installed. So you can go ahead and delete that top cell. Awesome. And even if there are packages that Hex doesn't have, you can simply import those.
Sweet, so I can still import packages easily, even though Hex has a bunch of packages installed in the standard library. And then if I run this cell again, it looks like everything should work properly. Sweet. So we're getting a failure down in this next cell. Do you know what this is about?
Yeah, so this cell is actually setting up a data connection, but Hex has a really easy way to store and set up your own data connections with all of your authentication credentials right inside of the tool. So if we pop over to that data sources tab, exactly, We can walk through the process of setting up a data connection, or in this case, just simply importing one that might already exist inside of our workspace.
Cool. So I've imported this demo Snowflake connection, and now I can just query it and delete this Python code?
Exactly.
Cool. So I'll delete this cell and then take this SQL, and I guess I'll just copy and paste it out of this Python block quote cell into a new SQL query.
So as we chatted about before, Hex actually has, the full support of a proper SQL IDE. So you don't have to be writing your block code inside of Python. You can actually leverage our SQL cells to run any SQL work.
Awesome. And it looks like I'm getting exactly the same results here as I was before. And I actually have a schema browser here where I can look at all the columns that I have available in this history day table, which is super helpful, even though we're not going to be looking at wind speed or snow depth or solar radiation. It's really helpful to know what you have access to so you're not flying blind. This is awesome.
The output of the SQL cell is actually a pandas data frame, which allows us to switch between SQL and Python continuously throughout our project.
Sweet. Okay, so the earlier data frame was being called zip codes. So I'm going to rename this to zip codes. And then I'm going to rename this to zips, because that's what it was being called, zips. And then we see that this error is resolved. So if I rerun this cell, then this should work below.
Yeah, you actually, Hex will basically create a DAG behind the scenes and associate those two different attributes to each other. So now you can see zips has a 1 next to it, which means that there's a single cell that's also referencing it. And over here on the right-hand side, you'll see a graph view basically painting out that lineage.
So basically, this cell is connected to that cell. So every time this cell runs, this cell will automatically rerun.
Exactly.
That's super cool. And all of these cells will also rerun all the way down below it.
Exactly. Hex is a fully reactive notebook. So as any changes to the upstream cells that are referencing downstream cells in our DAG will automatically rerun. So you don't actually have that reactivity issue that you were having before in Jupyter.
Cool. I guess this is failing here because I haven't yet turned this into a SQL cell. So I'll go and do that. Okay, sweet. So it looks like all these queries ran, but this query took a pretty long time to run. Took 1.5 minutes. Is there some way I can speed this up?
Totally. So if you pop open that dropdown on data frame, you'll see that we have 2 ways to speed this up. The first is actually you can enable cache on this cell. So in any situation, the query will just pull from the cache, and you can decide to do that if you want to do it when the project runs or when the initial app is actually loaded. The other option is that we have query mode, which means that the transformations in this query are actually going to be run inside of Snowflake, and we're only going to pull back a subset of results into Hex. It's basically lazily operating on that query.
Interesting. Okay, well, we need to use this right after, so I think I'm going to leave it as a data frame, but I'm going to turn that cache on so that this runs really swiftly the next time.
Awesome. And why don't we try and visualize the cell above to sort of show how easy it is to actually make these visualizations inside of Hex.
All right, how do I do that?
So if you press add in the middle there, you can click chart. And this is Hex is an easy way to build charts. So you can pull down the data frame of interest. Yeah, we can use wdata. In the x-axis, let's do dates. In the y-axis, we can plot temperature. And then in color, we can throw in city name. And really quickly, we're able to plot the results of what our temperature looks like over time based on our specific cities.
Cool. Well, that looks awesome. It was super easy to really quickly plot this data and get a feel for it.
Now, I know you might be more familiar with Python than SQL since you're used to it in a Jupyter notebook. So let me show you how you can actually use Snowpark for Python directly inside of Hex.
Cool.
The first thing you're doing is going to pop back over to that data sources tab. And if you click on the arrow pointing down from query, there's actually a magic button or an easy button to start up a Snowpark session.
Okay, done.
And you'll notice that the code to set up that session is automatically inputted into your notebook.
Cool. So maybe we'll turn this weather query into Snowpark code, or maybe we'll do this initial one. And then we'll turn this query into a Snowpark query. So I'm going to use this hex Snowpark session that I got, and maybe we'll call it data frame Snowpark, and I'll say hex Snowpark session table, and then I'm actually just going to copy this in because otherwise I'll probably make a mistake. I think we can delete the inner quotation marks in Snowpark. And then we want to rip out a couple of columns. We're getting postal code, city name, and then we're going to filter on the date and country, because there might be cities. Oops. There might be cities in more than one country with the same name. Okay, so we'll return this, and when I run this, sweet, it looks like it runs successfully, but this is just a Snowpark data frame, so we can't actually access it yet. So I'm going to import a couple of helper functions from Snowpark. Snowpark. We'll just grab the call helper function so that I can reference columns really easily later on. And then we'll add on the filters from here into that data frame. So we'll say data frame Snowpark, and we want to add a filter on city name. And we want to also add a filter on the date and on the country. I think I'm just going to actually speed through that so we don't waste time actually typing this out in real time. So that'll be slow. And then we want to just select the columns that we're interested in, city name and postal code. Oops. Keep hitting the enter button by accident. Postal code. And again, because this is Snowpark, when we run this, we're not going to get the results back because it hasn't actually run anything yet. It's just lazily evaluating this and saying, at some point in the future, this guy is going to ask for the results of this query, so let's get ready to run the query, but it returns pretty much instantly and nothing's actually been run yet. If we want to look at the data, we can say show 10 to get a quick glimpse of the data. And that returns really quickly and is evaluated. Snowflake's actually running the query. This looks good, like the data that we want. So I'm actually going to change this show to a toPandas call, and then we'll assign this to a data frame, and we called that zips. So I'll call this zips. We'll delete this one because we don't need it anymore. And then when I rerun this, everything should reactively rerun, like you said, and everything should look pretty much exactly the same. Awesome. Cool. Okay, so it looks like this didn't run successfully. It looks like it's failing pretty far down on cell 25. What's going on here?
So it looks like there's a bunch of different input parameters that this cell is actually requiring. So we can put these into what we call input cells to make it really easy for a user to filter on this data.
Cool. I'll make a city input, I guess. We'll call this city. I guess it's called city filter in the code. And it looks like I can make this dynamic and just feed it from our previous data source.
Exactly. You can take an existing data frame and then pull a specific column in to populate that.
Well, that's super easy. And the limit, it looks like it's just a number probably. So let's add a number and call it limit. So let's also call this limit. Okay. So I'll remove those. And it looks like that should get us here, but then there's another input down here. So I think I'm going to break this up into two different cells. So we'll run this one just to see. Great, so that worked. So I'm going to finish it up by adding the venue input, which is a drop-down off of that. So I'll do that same dynamic selection. We'll call this venue. Save. I guess I should add the limit to be something more than 0. We'll make this like 10. And then I delete this. Everything should work.
As you can see, these elements don't actually look a little bit like a notebook. They almost look more like an app, something you might see in a data app. So Hex actually has the ability to store all of these different problems that you're solving and outputs as a data app. Now let's kind of walk through how to build that. So if you click on the app tab in the top right corner, left corner, all of the components on the left-hand side in your notebook, you can simply add into your app here.
Cool. This is awesome. I think I'm just going to really quickly clean it up and maybe add a little bit of context up here, but spend most of the time on the configurable sections down below. So I'm going to get rid of a lot of this, get rid of all the feature engineering work behind the scenes, and then leave this section where people can actually mess with the values themselves and control it. And then I'll leave our final results. Although I might put these next to each other. Cute. And I'll get rid of some of the behind the scenes modeling, but leave the final answer. And cool. I think this is looking pretty good.
Do you think your boss would like this app?
I think so.
All right, so why don't you try and share it with me? And unlike in a Jupyter notebook where you might have to download and actually email it, you can add me right there inside of the share button.
I'll give you full access. Shared. So now what?
I'm going to jump in to this app and show you how we can actually collaborate together. And as you can
Cool.
see,
I see you up there.
Exactly. Now we're both inside of the notebook. We can actually work on building any parts of the logic view or the app view together. So if you pop back over to the logic view, you can see that I'm actually in that top cell in Markdown 0. You have the rights to take it over if you want to actually, start editing work at the same time. But these type of features ensure that we aren't going to clobber over each other's work.
Cool. And if I leave a comment for you here, you'll see that and be able to reply.
Exactly. So now that we've showed how we can actually share this, why don't we publish this out to the web and other folks can also look at the insights.
Sounds good. I'm going to click this big green publish button.
You can define any statuses or categories here. This might be helpful as you're building a number of different projects inside of your organization. So this one is, I'd say, in production at this point.
You said we're publishing this to the web, so I'll call it external, and then I should probably change these permissions to give anyone access.
Exactly. So you can share it to the web, or you can also just share it inside of your organization, but let's share it to the web.
Done.
Perfect. And then just hit publish.
Publish version. Published app link copied to clipboard. So if I visit this URL, it looks like I get a live interactive view of my app. And you're telling me I can send this to absolutely anybody and they'll be able to access it just the same?
Yeah. And we'll even send it to everyone who's on our build session today so they can take a look at the notebook that we built together.
Super cool. Well, awesome. Thanks, Ariel. This is actually a lot better than my Jupyter notebook that I had before. Thanks for helping me make it over.
Awesome. Thanks all for joining us.
Hello. We've got a breaking news alert. Now bear with me as we don't quite understand what's going on as of yet. Our Channel 8 News team is being bombarded by reports of what people are calling data superheroes. Here's what we know so far. Multiple individuals have been spotted all over the globe doing what can only be described as saving our data. We have this clip submitted to us by Felipe Hava, and it seems to show a figure flying in and doing something incredible to the old industrial mill on 53rd Avenue. That is simply amazing. Now joining us live on the scene is Elsa Mayer. Elsa, give us an idea of what's going on over there.
Thanks, Leif. I'm here downtown where moments ago, 2 individuals were spotted lifting, rising up alongside this building here. This is truly unbelievable. If it weren't for the footage captured by Daniel Myers, I wouldn't believe it myself. Leif, back to you.
Thanks, Elsa. Stay safe out there. Here now is some footage coming out of Amsterdam of what seems to be a person holding back a tsunami of data. I'm not sure what's even going on here. Adding to all of this Cities around the world are starting to see this symbol pop up. What does it mean? Who are these people? It looks like these data superheroes are somehow saving our data. I'm not sure what's going on, but I can tell you this. I'm sure glad they're on our side. For Channel 8 News, this is Late Rausha signing off.